Hello, my name is Clinton Beutel. I manage the Center of Excellence in Automation and Robotics at Alexandra Hills State High School. I'm pleased to have the opportunity to describe some of the special projects that we run through our center and to share our thoughts on the future of robotics education at the high school level. Our school has a long-standing partnership with the Queensland Minerals and Energy Academy. QMEA is a gateway to industry initiative supported by the Queensland Government. Through our QMEA partnership, students have been involved in special activities and learned about employment opportunities in mining. As the mining industry significantly modernized in recent years, we turned our partnership focus to the METS sector: mining, equipment, technology, and services. From this, we established Education Queensland's only Centre of Excellence in Automation and Robotics in 2016. Since that time, we have expanded our robotics and electronics resources and programs, and we're excited to launch our Robotics and Advanced Manufacturing Complex earlier this year. One of the highlight features in the new complex is our Research and Development Lab. In this lab, we have a range of 3D printers and an industrial laser CNC unit. The school also owns other 3D printers and a second laser CNC, with this equipment complementing our traditional industrial design facilities, where students learn machining, sheet metal work, and welding. The new resources have allowed our students to get a taste of advanced manufacture techniques. At the Center of Excellence, students work with specialist equipment, including a fleet of industry-standard drones like this Inspire drone. We also have a class set of small robotic arms produced by a Brisbane startup company. These arms were also purchased by QUT as part of their mechatronics program. We use the robotic arms with students from Year 7, building task complexity as students get older. The arms can be coded in Python or by recording physical or simulated environment manipulation and replaying the movement. As much as our students enjoy using the outstanding resources at the Center of Excellence, our most valuable asset is our industry partnerships. These companies provide advice on the skills needed in industry and examples of real-world projects. Stories of prototypes and challenges in these companies helps us to encourage persistence and problem-solving habits with our students. Seeing innovative solutions from local companies encourages students to approach problems with creativity and to realize that Australian products compete well on the world stage. With the rapidly changing nature of work, our goal is to prepare students for new ways of working, not to prepare students for particular jobs or courses of study. We try to encourage students to study STEM-related subjects and to prepare them for new service and manufacturing opportunities. Here are some of the resources that we use with our junior students. You'll find these small educational robots and mini drones in primary and secondary schools across Australia. Typically, they are used for simple navigation challenges or coding tasks, and in some cases include a design element where students try to meet a particular objective. It is also very common for high schools to have some 3D printers and maybe some desktop laser engravers. Students will usually have an opportunity to make computer-aided designs to plan out the product they are going to create. In addition to our extensive resources, we like to do business differently at the Center of Excellence. We look to our industry partners to inspire the projects that our students complete. Wherever possible, we try to introduce a community benefit or service element. I think we have enough social media app developers at this point in time. We encourage our students to be open to failure. We want them to rapid prototype and build problem-solving habits. This is not a trait that comes naturally to them. We encourage students to think creatively and realize that innovative solutions can have a broad market. Let me give you some examples of this. A terrific example of an industry-inspired project is the firefighting robotic vehicles. Our students are working on a miniature version of the BAI-5 firefighting robot. What an amazing robot to be produced by a small Brisbane-based company with units sold to CSIRO and NASA's Jet Propulsion Labs. Later this year, the team from BIA5 are meeting with our students to describe the design challenges and prototype steps they worked through. We're also excited to introduce students to the idea of a robot that keeps workers and communities safer, rather than simply displacing them from their jobs. Another industry-inspired project recently completed by our students is a remote operations and underground rescue challenge. You will see in the image on the right a simulated mine shaft that a robot must navigate using an infrared camera to locate a Barbie doll in distress. Although the setup is very simple, it introduces students to a real-life challenge. We know that in years to come, vertical farming will be very important. The setup you see here has been donated to us by research company Green Bio. It is a smaller version of their massive vertical farming facility. Green Bio are currently working with ACRV to investigate robotic harvesting options. Some of our students are using the setup to grow decorative and salad plants, while others are designing simple plant detection using light sensors, and others extendable arms as remote harvesting options. Another great project completed by our students was the development of a web-based app for Glencore Mount Isa mines. The app will actually be used by workers on the mine site to complete safety checklists before their shift, and will be able to replace a paper-based check-in currently used. It is very exciting for students to be completing a genuine project for a significant company like MIM. Following from Brisbane hosting the World Drones Conference, we began making extensive inquiries about our students gaining drone pilot qualifications while at school. The training was not subsidised at that time and was too costly for most students to complete. Initially, we were told to wait a year or two, but thankfully this was reviewed and we were excited to work with an RTO to introduce the program. Our students now study to complete Certificate 3 in Aviation and can continue to complete the industry standard CASA remote pilot license. We already have one of our program graduates employed full-time with a UAV training company. Once our students have obtained their drone pilot license, we make sure that they build their skills with industry-driven projects. After all, there's a limit on the number of real estate aerial photography jobs available. You can see here an asset inspection of one of our school's air conditioning units. We also recently purchased a thermal drone camera that will allow pilots to conduct wildlife monitoring. Our industry partners have helped us to identify the best software for our students to use. Thanks to Vatira, our students will be using industry standard drone mapping software, Drone Deploy. Our students will also be using Unity software to develop their VR projects, following advice from Immersive Technologies, who make virtual reality training packages for the mining industry. Thanks to some great advice from companies like Hastings Deer and Cat and BIA5, we are looking to blur the lines of traditional study at our school. We cannot have our academic pathway students working in the classroom without any hands-on skills. And we do not want students with vocational skills but missing technological knowledge. To try to achieve this, we are running school-based subjects that combine computer-aided design and advanced manufacturing alongside traditional metal fabrication such as machining, sheet metal work, and welding. For our academic pathway students, they will complete workshop incursion days to introduce diverse skills. This fits into the concept of no-collar workers as promoted by CSIRO's Elliot Duff. As well as developing skill diversity, we see that another pressing need for schools is to prepare students for jobs as technicians. A modernizing workforce will need technicians to install and use robots, use advanced manufacturing tools, and provide maintenance for robotic systems. We believe that in well-equipped settings, high school students could be introduced to augmented work with collaborative robots. As with drone pilot licensing, we are interested in our high school students obtaining industry certifications for using collaborative robots. These qualifications could lead to further study at TAFE or university. I hope you can see that high schools have an important role in encouraging the study of robotics, and in well-equipped centres like ours, can play an important role in preparing modern thinking workforce. Thank you.